Math Morning, Mr. Dirk is back at it again. Today we'll be solving quadratics by graphing. Let's dive right in. And by dive in, I mean let's watch the world record belly flop. Here it is. Wow, that was great. So we're going to do some diving problems today. That's why I showed you that. So get ready. Let's go. So here's an equation, and we're going to solve by factoring. This is from an old video, solve quadratics by factoring. So let's see. 0 equals, this becomes x plus 3 times x minus 1. If you're like, what is that? Go back, watch the old video. Now I need to think. This is a property when I multiply. If one side equals 0, then the whole thing will equal 0. That's called the zero product property. So I can say x plus 3 equals 0, or x minus 1 equals 0, minus 3, x equals negative 3, plus 1, x equals 1. Okay, so these are my two answers. We also learned some other things in the last video, right? We have A, B, and C. This one, A is 1, B is 2, and C is minus 3. All right, I took those are the coefficients over here. If I want to find the axis of symmetry, that formula is x equals negative b over 2a. Alright, the b is 2, so it's negative 2 over 2, and a is 1. Alright, so negative 2, that's really 2. So negative 2 divided by 2 is negative 1. So the axis of symmetry is x equals negative 1. Alright, there we go. So I can draw this. It's a vertical line along x equals 1. Now another thing I learned was finding the vertex. The vertex. That's when you take the x value for the axis of symmetry and plug it into the original equation, and that will give you a point. Okay, so we said x is negative 1, so that's really negative 1 squared plus 2 times minus 1 minus 3. And that becomes 1, that's minus 2, that's minus 3. 1 minus 2 is negative 1, minus 3 is negative 4. So our vertex, this is the y value, so x is negative 1, y is negative 4. So this point right here is our vertex. Negative 1, negative 4. Bam, right there. That's our vertex. Now if I wanted to graph the rest of this, you can make a table. Make an XY table, fill everything in. You could say, negative 3, negative 2, negative 1, 0, 1, 2, 3. Fill it in, okay? We could do that, but I'm going to show you a shorter way. So when we factor this, right, we got x equals negative 3 or 1. When this was, you can make this an equation, put y here instead of 0. And this is saying when x is negative 3, that y must be 0. Or when x is 1, y is 0. So this chart, right, when x is negative 3, y is 0. Or when x is 1, y is 0. And these are important points. This is how you solve it. These are called roots. So I can put those 2 points, negative 3, 0. Negative 3, 0, that's right there. And 1, 0. 1, 0, that's right there. You see they're both equal distance away from the axis of symmetry. And I'm just going to go ahead and connect these points and make it look like a parabola. Alright, so this right now, actually this one could be a little more in like that. This is a quadratic function. We've got the vertex, we've got the 2 points. These are the zeros or the roots of a function. And we solved it by graphing. So this is what we're going to do today. Let's do some more. And just to reiterate, when I solve this, I'm looking for where does this graph cross the x-axis, and that is right there and right there. So now let's do some definitions. We were just talking about the roots. That's where a function equals 0. So another word for that, you might hear them called x-intercepts. I know I say that sometimes. X-intercepts, you might also hear these being called zeros, or sometimes they're called solutions. And these are all basically the same things, but with some minor differences. So if we look at this first one, it's already graphed for you. We need to find the roots, right? So this is where a function equals 0, or the x-intercepts. So we got one right there, one right there. So x equals 1, and there's one at 5. So x is 1 and 5. 2 roots. The vertex, right, that's the lowest point on this one. If we look, it's 3, negative 4. So 3, negative 4. We write that one as a point. Over here, x-intercepts, right, the same idea. Where does this cross the x-axis? But when they're asking you for x-intercepts, they want the actual point. So this is going to be negative 3, 0, and 1, 0. Those are the 2 points, the x-intercepts. The min/maximum, well, this one has a maximum, right? It's the highest point, same as the vertex, and it's negative 1, 2. Negative 1, 2. Alright, this one, 0 or zeros. Well, interesting, this one only has 1, right? It's right there. So sometimes a graph might have 2 x-intercepts, or 1. Sometimes they have 0. But this one is negative 1, negative 2, negative 3. So x equals negative 4. Negative 1, 2, 3, 4. And the vertex happens to be the same, right? It is x is negative 4. And, x is negative 4, and the y is 0. Alright, so now we're going to solve by graphing again. In the future, next year, you're going to get a nice graphing calculator. We're going to use Desmos right now. So you can go to desmos.com. So let's do this first one. 0 equals 2x squared minus 3x minus 7. Oh, that's not the right website. Oh, my bad. Alright, so, and instead of 0, right, when we graph this, we can change it to y. So we have y equals 2x squared minus 3x minus 7. Alright, so here's our graph. But I can't see the whole thing, right? How can I fix that? Well, I can zoom out. So let me do a little zoom out. Okay, there's my graph. Make sure you can see that part. Now the solutions, right? This is where it crosses the x-axis. You want to graph these when you can't really factor them. They get some crazy answers. So you can click right on there and right on that point, and it gives you the answers. Okay, I'm going to take a picture of this. Bam. Put it back over here. So if you come up with this from Desmos, what are our 2 solutions, right? One is, let's see here, moving the screen around. We've got x equals this first one, negative 1.266 and 2.766. That's simple. There are your answers. And when you get a graphing calculator, I can show you how to do this, but you're going to learn more about that next year. This one over here. So before we can graph this, right, we need to make it equal 0. You can actually put it into Desmos, but with a graphing calculator you can't, so we should practice putting it equal to 0. So what I want to do is, let's see here, if I do a plus 8, right, this becomes 0, and I do a plus 8 on this side, I'll have 1/2 x squared plus 5x plus 8. Alright, now I can grab this in Desmos. Still is going to be y equals 1/2 x squared plus 5x and plus 8. There we go. This one I can see it pretty well. I click right there, ba-boom, right there. All right, we got some nice looking numbers. I'm gonna take a picture of this, put it back. So with this one, looks like our answers are going to be, or our solutions will be -8 and -2. Alright, so with this one, x equals -8 and -2, because there they are right there. Alright, this one again, we want it to equal 0. So let me do a -2x on this side, or 2x squared, and a -2x squared on that side. That cancels, and I have 0 equals -2x squared plus x minus 5. You notice this one has a -2x, so let's see how that looks. Alright, let me erase the old one. -2x squared plus x minus 5. I can't see it. Let me zoom out. Interesting looking graph. Well, it looks like it doesn't cross the x-axis at all. Let me take a picture of that just for fun. Bring it back over here. And so when it doesn't cross the x-axis at all, are there any solutions to this? No, there's no solutions, right? It never crosses the x-axis, so this one you just write no solutions. Boom, done. So now we're going to find the minimum maximum by graphing. This is the same as the vertex, so let's do that. All right, this one, let's put it right into Desmos. 2x squared plus 3x minus 5. Alright, here we go. We've got 2x squared plus 3x minus 5. Is that right? Alright, there we go. So here's the graph. The vertex, nice thing about Desmos, is right here. If I click, I got it. Right there. Simple as that. So that is that a minimum or maximum? Well, if it's at the bottom, if it's the lowest point, it is a minimum. So at this point, that's the minimum right there. -0.75, -6.125. Piece of cake. Write that down. The next one, before I put it in Desmos, we should solve for 0. Alright, how do we do that? Oop, why isn't that working? There we go. So, I want to get everything on one side. So I'm going to do -3 over 4x squared. -3 over 4x squared. That's a minus. Alright, that cancels. 0 equals -3 over 4x squared minus 7x plus 2. Put that right in Desmos. Okay. -3 divided by 4x squared minus 7x plus 2. There we go. Okay, I can't see it. Let me zoom out. Boop. I got him right there. Okay, take a picture of this bad boy. Bring it back over. Drag it over there. And this is a minimum or maximum? It is a maximum, right? And there it is. That's the point. -4.667 and 18.333. All right. Next one. Here we go. Whew. I can just type that one in. It's already equal to 0. We've got some decimals. So we've got 0.6x squared. Remember, we always make it equal to y. So 0.6x squared plus 7.5x plus 8. Alright, again, can't see it. Click on it. That's the minimum right there. And it's minimum because it's at the bottom. So let me select it and drag it over. Oop, I made an extra copy. So that point right there, negative 6.25, negative 15.438 is the minimum. Alright, here's a diving problem. A cliff diver, Mr. D, that's me, stands on a 70-foot cliff. He jumps with an initial velocity of 8 feet per second. Here's an equation that represents that. Alright, so here I am. I'm standing on a cliff. That's a nice cliff. It says 70 feet tall. It says 70 feet. And I jump off. This is a cliff. I jump off. Go into the water down below. This is the water. Okay? So let's make some sense of this. Well, it says 70-foot cliff. That's important. And a velocity of 8 feet per second. Let me circle that one. If I'm looking down here, we got initial velocity is the v, and the height is h. So I can actually put some numbers in here. So this will be s of t, right? T is time, and s of t is the height. So minus the 16 t squared. The v, that's the initial velocity. So that was 8 feet per second. So I could put in an 8 plus 8t, and h is the initial height. That's where I started at. Plus 70. 8t plus 70. Alright, so I've got this equation. Now I need to find out when will I hit the water and what will be my maximum height. Okay, how can I do this? Well, I've got a graph. And actually, let me just clean this up a little bit. It's s of t equals negative 16t squared plus 8t plus 70. Okay, same thing, it's just a little bit neater. So you can even erase that if you want. Alright, so what am I going to do? Well, graph this. Let me use Desmos and see how it looks. Alright, so I just graphed this, but I want to make it look, you know, more like the picture I drew. So I guess I need to zoom out a little bit, or maybe zoom in. Okay, so there is the top of the cliff. I dove up, boom, like that. And to make it look even better, right, if I hit this little wrench up here, that's the settings. Okay, the x-axis. This is the smallest number that x can be, right? I want it to be 0. Okay? 0. The biggest number, well, let's see here, that's like 5, 10, 15, 20. So if I put in a 5 for the largest number for x, the greatest number, boom, like that. Okay, that looks a little bit better. What was my y? Okay, well, I'll do negative 10 to start just because it's like, you can go underwater. And then the maximum, I'll make it 80. Okay, look at that. So let me take a picture of this, bring it back over, and you could graph this too. And what you should do is try to find the answer to the 2 questions that are on this paper. If I can see them, you can answer them. Alright, so there's my graph. So when will Mr. D hit the water? What is my maximum height? Okay, pause it, try it. Alright, so I'm going back to Desmos. I click here. That gives me the maximum. That gives me one of the solutions. Let me take a picture of this bad boy. Bring it back. Alright, so when will I hit the water? Alright. When will I hit the water? So it looks like, you know, I jump off the cliff and I'm going to hit the water in 2.357 seconds, right? Right down on the right. So when I hit the water, 2.357 seconds. And what's my maximum height? Well, okay, so the x is 2.5 or 0.25 seconds, and this is my maximum height, the 71 feet. So how high did I jump? 1 foot? Ah, I'm better than that. Alright, but that's my maximum height, and I'll hit the water in 2.357 seconds. Alright, good luck. On the mastery check, good luck with the packet. Dirk is out, and we're going to end with, how do you cliff dive without any cliffs, without any water? I'm going to show you right now. You'll become a stranger.